Hello everyone, welcome to another video lecture on the chapter The Solid State. In this video, we will be discussing about crystal lattices and unit cells. The constituent particles of a crystalline solid are arranged in a definite fashion in three-dimensional space. Such a regular arrangement of the constituent particles, that is atoms, ions or molecules, of a crystal in three-dimensional space is called a crystal lattice or space lattice. Now from the complete space lattice, it is possible to select a smallest three-dimensional portion which repeats itself in different directions to generate the complete space lattice. This is what we call a unit cell. A unit cell is characterized by 6 parameters, which are the axial lengths A, B and C, the axial angles alpha, beta and gamma. Based on the parameters of the unit cell, there are 7 types of unit cells. These are also called the crystal systems or crystal habits, because any crystalline solid must belong to any one of these unit cells. In the various types of unit cells as described, it was assumed that the particles are present only at the corners of the unit cells. However, it has been observed that the particles may present not only at the corners but also present at some special positions within the unit cell. Hence, unit cells may be broadly divided into 2 categories. Primitive cells. These unit cells are the ones in which the constituent particles are present only at the corners. There are 7 types of primitive cells. Non-primitive or centered unit cells are those unit cells in which the constituent particles are present not only at the corners of the unit cells, but also at some other positions. There are 3 types of non-primitive unit cells. Face-centered unit cell. Here, the particles are present not only at the corners, but are also present at the center of each face of the unit cell. End-centered unit cell. In this type of unit cell, in addition to the particles at the corners, there are particles at the centers of any 2 opposite faces. In a body-centered unit cell, in addition to the particles at the corners, there is also one particle that is present at the center within the body of the unit cell. Every crystal system does not have all the 4 types of unit cells, that is, simple, face-centered, end-centered and body-centered. Hence, there are only 14 types of space lattices corresponding to 7 crystal systems. These 14 lattices corresponding to the 7 crystal systems are also known as Bravais lattices. Now let us talk about the number of atoms per unit cell. Firstly, let us discuss primitive or simple cubic unit cell. A simple cubic unit cell has only 8 atoms on the corners. An atom at the corners is shared by 8 unit cells. As the contribution of each atom is 1 by 8. Therefore, the number of atoms present per unit cell would be equal to 1 by 8 into 8, which is equal to 1. When we talk about a body-centered unit cell, this lattice has 8 atoms on the corners and 1 atom within the body. Let us calculate the number of atoms per unit cell. So in this case, the contribution by 8 atoms present at the corners is equal to 1 by 8 into 8, which is equal to 1. And here there is one atom present within the body. So therefore, this is equal to 1. And thus, the number of atoms present in the unit cell would be equal to 2. Now, when we talk about the face-centered unit cell, this lattice has 8 atoms on the corners and 6 atoms on the faces, 1 on each face. An atom on the face is shared between 2 unit cells. So therefore, the number of atoms present in a face-centered cubic unit cell would be equal to 4.